this thing working? Good. Either I smell or I'm very intimidating, considering the lack of people at the front here. But over the next 20 minutes, half an hour or so, we're going to have a bit of a fun time talking about the strange, scary world of monitoring serverless applications, because in the last sort of 10 years or so, with the growth of cloud platforms, we've also seen a growth in serverless applications. And at least in an open source observability world, we haven't really been able to keep up. For the most part, if you operate a serverless application, you are relegated to paying your cloud provider some money to use whatever vendor lock-in product they have, or paying someone like Datadog even more money to try and avoid that, which is a bit sad, right? And that brings me to Cloudflare Workers. This isn't a sales pitch. I just want to try and give a bit of flavor to our experience. About 5 years ago now, we made a thing called Cloudflare Workers. It's our own serverless platform. And then we started using it, which was tremendously frustrating from an observability standpoint, because we had to figure out how we were going to monitor these things. And so today I want to take you on a bit of a journey through Cloudflare's evolution into the serverless space and how we monitor the increasingly large chunk of Cloudflare that is based on Cloudflare Workers, despite that terrifying circular dependency. But before we get into that, my name's Colin Douch. I live in Australia. Don't let my accent fool you. I'm not British. I am originally a Kiwi, although I have been everywhere. I currently tech lead our observability platform team at Cloudflare. It's an interesting job. We build all the tools that allow Cloudflare engineers to monitor and debug Cloudflare. And there's a lot to talk about there. All the different types of telemetry we want to collect: metrics, logs, traces. Today I want to talk specifically about time series metrics because it's the most interesting. And from a time series standpoint, I think probably most of us will agree that Prometheus is sort of the de facto standard for open source metrics collection and storage. And it's pretty great. At Cloudflare we have somewhere in the mid 10 figures of time series running through our Prometheus infrastructure, and does that without breaking a sweat. And I know we have at least a couple of Prometheus maintainers in the audience today, so thank you, because it makes my life a hell of a lot easier. But if we're being honest, Prometheus has some downsides as well. Makes some assumptions that perhaps, while innovative, sort of lock us into a particular pattern. And you'll have to excuse this image here. Turns out when you name your system after a man who was chained to a rock and has his liver eaten out, it's really hard to find safe for work stock images. But at a high level, Prometheus assumes three things about your service. It assumes that your system lives long enough to be discovered and scraped. It assumes that your system is network enabled, and it assumes that your system can do its own aggregation. And those are a bit opaque, so let's break it down a bit. Firstly, your system has to live long enough to be discovered and scraped. Rather innovatively, Prometheus uses a pull-based model for metrics collection. That is, instead of your system actively pushing metrics to Prometheus, Prometheus will reach out to your service and pull metrics back. But it doesn't do this continuously, right? It does it on a timer. So every 10 seconds, every 15 seconds, it will reach out to your service, which means practically your service has to live for 10 seconds, 15 seconds in order to be around for Prometheus to scrape it. At the same time, this sort of goes hand in hand with the first one, your system has to be network enabled. It has to be able to bind on a port. It has to be able to set up an HTTP server or a gRPC server if you're being fancy, in order to in order to provide an interface for Prometheus to pull metrics back. And on top of that, it needs to be reachable from Prometheus. So we need to set up firewall rules, and we need to set up TLS certificates and authentication if we want to do it, and then we have to handle PKI infrastructure, and it gets really messy when you get onto the gritty details. And thirdly, Prometheus assumes that your system can do its own aggregation, and this is a bit opaque. It's easier to demonstrate this with a bit of a counterexample. If we imagine, say, a service that only ever processes one request. So it starts up, processes a request, and exits. What would a request counter metric look like in that? Well, if we ignore the previous two, well, our system starts up, it processes a request, it sends a 1 to Prometheus, because it's processed one request, and then it shuts down. And then our service starts up again, it processes a request, it sends a 1 to Prometheus, and then it shuts down. And so from Prometheus's point of view, it's seeing a 1, and then a 1, and then a 1, and then a 1. And that's not our request count, right? That's just a metric that is a 1. So in effect, Prometheus assumes that you can do your own aggregations. It assumes that you're able to count a 1, and then a 2, and then a 3, which is an interesting subtlety. But if we sort of summarize those a bit, Prometheus is very well suited to a particular model of service, a service that is long-running, a service that is network-enabled, a service that can do multiple things and define how metrics behave over time. And if we look at that from our serverless point of view, well, our serverless functions live for, hundreds of milliseconds, seconds at worst. Our serverless functions aren't network-enabled. We can't bind on ports. We can't set up HTTP servers. And even if we could, that sort of becomes not serverless, right? And then our serverless functions only ever process one request, so they can't do their own aggregation. And so all of these base architecture assumptions sort of fail in the serverless case. And these were the main problems that we sort of identified when we were first starting this journey. But once we'd sort of identified these problems, we wanted to go out to our engineering teams and work out what they were doing, right? Because while we had been fumbling the ball, our engineering teams aren't dumb. They've started up their own monitoring. And so we wanted to work out what they were doing to see whether we could, replicate it. We wanted to work out what sort of metrics they were doing. Were they using counters or gauges or histograms? And we wanted to know sort of what semantics they were applying to those. In particular, gauges and Prometheus can have some interesting semantics. So we did a bit of a survey, and we went out to engineering teams and had a chat, as you do. And what we found was a giant dumpster fire. Without an official solution, every team had just done their own thing. From a what perspective, it was terrifying, because every team seemingly had their own bespoke solution. And from a semantics point of view, it became really interesting just how many sort of logical types of metrics we had. And let's look into those firstly, because teams at a very basic level needed counters, right? Things that you can sum up. You get a 1, 1, 1, you output a 3. Those are kind of basic, right? Request counters, error counters, whatever. At the same time, teams need gauges, things that can go up and down, standard Prometheus data type. Then we have histograms, and histograms are really deceptive in a push-based world, because at a high level you can just sum up buckets, right? You have a bucket and you can just add in new counts as they come in, but what happens if we get 2 pushes from a serverless function that have different buckets? How do we sum across those? How do we aggregate them? And in Prometheus we have a metric type called a summary. Like, how do you even aggregate that? You can't. And at the same time, we had teams that use infometrics, and these ones are fascinating to me, because if you've ever used like client Golang or something in Prometheus, you'll see like a Go build information metric. This is a metric that has a value of 1 and a label set that represents some metadata, like the version of Go that it was compiled with. And these are really interesting because they're not defined by anything inherent in the metric. They're defined by how the application treats it over time. Because in a more traditional application, these are fixed metrics, right? You bake the Go build info metric into your application. When your application starts up, it exposes this metric. And then when you deploy a new version, your old version shuts down, that old label set stops being produced, and the new version starts up, and we get a new label set. And that's really interesting because it's intrinsic in how we manage the service, not in the service itself. And in a serverless world, we don't have this sort of life cycle of a service in the same way. So these infometrics were interesting to work around. And there is some prior art here, right? The industry isn't that slow moving. There is some amount of effort to try and monitor these. And the first one we might stumble across, in fact it's the first result in Google if you try and search it, is the push gateway. The push gateway is a sort of in the Prometheus ecosystem type system. The idea is you can push Prometheus text exposition to the push gateway and it will re-expose that text exposition to Prometheus. But if you read the docs, it's a bit lying because it tells you that the only real use case for the push gateway is for things like batch jobs. If you run a batch job, it generates some metrics, but you don't want to have to keep that batch job around for Prometheus to scrape it. So it sort of solves that first problem we have. We don't have to listen on a port, and we don't have to live around long enough because the push gateway can handle that, but it can't do any of the aggregations we want. And so if you dig a bit further in the second result of Google, you will get the aggregation gateway, which is made by Weaveworks and now abandoned. But it functions very similar to the push gateway. You can push metrics into it, and it will re-expose them to Prometheus. The difference is that instead of replacing old metrics as new ones come in, it will aggregate them. And by aggregate, we just mean sum. It's a fancy word. So ostensibly, the push gateway, well, the aggregation gateway solves all of our problems. We can push metrics from our serverless functions. We can aggregate them. So what's the issue? But the aggregation gateway doesn't sort of support all of these different semantics we want. It doesn't handle gauges at all. Histograms are real weird with it. Infometrics are just completely out of it. At the same time, we found teams had built their own internal bespoke thing that sort of took the push gateway, took the aggregation gateway, and like stitched them together in some Mary Shelley style abomination. It was very scary, not unlike Mary Shelley's novel, and it was bad. It used random logic to route different metrics to different push gateway or aggregation gateway. Very scary, but provided an interesting base to work off of. At the same time, we were investigating a lot of sort of event-based solutions. We live in an observability world now, so we're all about event-based systems, and there is some work to sort of deprecate time series internally anyway. And there's various systems there. Events to Prom, made by Yana, that takes OpenTelemetry events and aggregates them into Prometheus metrics. We have an internal thing called Cleodora. We gave a talk on that earlier in the year. All the same idea. You can send events out of an application and then aggregate time series metrics outside of that application, which means you can aggregate on the fly. You don't have to build your application to have certain metrics. But we didn't want to break up the ecosystem that much. We wanted to provide some level of compatibility, so you didn't have to worry about whether you were building a more traditional application or a serverless application. So we didn't want to get rid of Prometheus too quickly. And so it became pretty clear that we would need to build our own thing. And so we did. And this is it. The open source version I call the Gravel Gateway, just because you'll find I really like this pun. I'm from a mining background, and in mining we have a thing called an aggregate. It's like a mixture of rock offcuts and sand and things. So I think it's very funny. Literally no one else does. So if I could have a pity laugh, that would be nice. Thank you. Code is there. It's written in Rust, so caveat emptor in that bit. But it provides us an interesting sort of base to work off of. Some functional requirements we had when we were building this thing. We had to accept pushes like the push gateway. We had to aggregate like the aggregation gateway, but we needed to support so many more semantics than the aggregation gateway supported, right? We had all of these different semantics that we had identified with our engineering teams, from how gauges were handled to how histograms were handled, these infometrics. And particularly gauges there are kind of interesting, because how do we aggregate gauges? We can replace old values as they come in. This is what the aggregation gateway and the push gateway do. But if we're running, say, thousands of serverless functions, it kind of feels wasteful to throw away 999 of those observations. So we wanted to provide the ability to do sort of statistical functions over those incoming values, take a mean, take a median, take a P95, or whatever across incoming values. And that gets kind of tricky. Because the big question is, how do we express all of the different semantics that we want to, while constraining ourselves to Prometheus text exposition? Because text exposition is interesting, but not that verbose. You can see here we have two different metrics in Prometheus text exposition. They are both gauges. The first one, go threads, goes up and down, right? It's the number of threads we're using. But the second one, build info there, is an info metric, and there's nothing inherent in that text exposition that says which one is which. Right? So we have all of these different semantics that we want to communicate to the gateway to define how it's going to aggregate them, but where do we put it? And so there's a number of different configurable fields in the text exposition. We could throw something into the help text, maybe. We could do something with the metric name, but ultimately we decided let's just throw in a label, because that's the most free-form part of text exposition you're going to get. And so that's what it looks like. In the Gravel Gateway, you can define a clear mode that defines how the gateway will aggregate your metrics. For example, you can specify a clear mode of sum, which technical difficulties. You can define a clear mode of sum, which aggregates all of your metrics like a counter. It sums up all of your different metrics into one final thing. So you can push a 1, and then you can push a 1, and you get a 2 out the other end. That's, I mean, math works, right? We define a default clear mode for all of the different types of metrics. So this is the default for counters. If we push a 1 and then a 1, we get a 2. Not too difficult. Info metrics, we can define those with family clear mode. This is not entirely obvious why it's called family. In Prometheus, a metric family is a collection of metrics that have the same name and label names. So the idea is that when a new label set comes along, that is a new set of values for those label names, we clear out the entire family, that is every metric that has a different label set. And this pretty well emulates our info metric behavior. And at the same time, I mentioned we wanted to take statistical functions over our gauge values, and this is non-trivial because a metric in Prometheus world is a number, right? It's a float. At least at the moment, native histograms are coming along. They're quite interesting, but it's a single observation. A request counter has a value, a gauge has a value, but taking a statistical function requires us to keep a range of values, right? We have to keep a mean, we have to keep a median. That means we have to keep all of the observations in order to calculate those. And when you have thousands upon thousands of requests coming in, keeping thousands upon thousands of raw observations gets expensive in terms of memory very, very quickly. So we actually borrowed a concept from an internal system we have, I mentioned before, Cleardora. Cleardora aggregates events to produce metrics. This aggregates metrics to produce metrics. The general idea is that instead of storing raw observations, we instead keep a circular buffer of effectively weighted buckets. So if we have a mean over 5 minutes, we split that 5 minutes up into 10-second chunks, and each bucket will contain the mean of values observed over that time. And then to produce a final observation, we then take a mean over all of those buckets, weighted by its weight. And that allows us to keep doing statistical functions without exploding our memory into some unbounded amount at the cost of a little bit of accuracy, because we're actually taking an aggregate over aggregates. If you want to learn more about that, feel free to come up later. Because we're only adding a label. It means that we are fully compatible with all of the existing client libraries, which is nice because it means you don't have to worry about doing things differently in a serverless world versus a more traditional application. Because we're engineers, we like code. Oh, good, you can see that. It's not too bright. Good. Here's some JavaScript. I am not a JavaScript programmer, but Cloudflare Workers likes JavaScript. You can see we just define a push gateway interface. For our counters, we don't even need to do anything because of that default clear mode for counters. For a gauge, we want it to have an info metric, and so we define it as a clear mode family, and we can just push it. Entirely compatible. But that's sort of where we are now, but we're looking at the future. Right? There's a lot of interesting work coming along the way. For starters, we're continuing to work on the Gravel gateway. We want to work on scaling it out. We have some internal stuff, but the open source version always lags behind that for legal. I don't pretend to understand it. At the same time, we're doing more interesting aggregations. We want to take aggregates over subsets of label sets, or perhaps take even more interesting statistical functions. We're also rewriting the Pebble system. ClearDora internally is going over a big internal rewrite. At the same time, you have things like open metrics. Open metrics attempts to codify the Prometheus text exposition, and it defines a whole range of different types than Prometheus. So Prometheus will only give you counters, gauges, histograms, summaries. I'm probably missing one. Open metrics defines a whole bunch more. It defines, for example, info metrics or state set metrics or enums, sort of thing. So maybe we can get rid of the clear mode in the future and just rely on open metrics types. At the same time, we have things like OpenTelemetry, and there's a couple of interesting angles there, because OpenTelemetry firstly defines how we can ship traces, and as mentioned, there are various things that allow you to aggregate those traces into an output metric, but perhaps less radical than just getting rid of time series altogether. OpenTelemetry has a really interesting metric spec, and in fact it defines two different types of counter. We have the sort of absolute counter, like a Prometheus thing at the moment, but we also have a delta counter, which is sort of what we want, right? We push a delta of one, we push a delta of one, and it sums up into an output thing. So there's some really interesting work in OpenTelemetry to do there. But that's about it. That's all I have. If you have any questions, we have things, but otherwise slides are on my website or QR code there. Code is QR code there. Yeah, feel free to ask questions, come up and tell me how terrible I am. I already know. But beyond that.
Thank you, Colin. So, like he said, are there any questions in the room?
Hi, thanks for the talk. Very interesting. Just simple question: do you keep those? I already forgot, like clean code metrics, or do you strip them because they would like extend your cardinality?
Yeah. So the gateway strips out that label before exposing it to Prometheus, so it's entirely transparent from the Prometheus standpoint.
Are there any more questions?
Fantastic. I must have all stunned you.
Well, then that's it. Thank you so much.
Cool.